Hey guys, I'm going to go through 5.5 today, and 5.5 is bases other than E in their applications. I don't know if I'll go through many of those applications. Typically it has to deal with like financial growth and stuff. Most growth things. So that's really useful if you want to talk about they talk about bacterial growth, but also the application might be like a financial growth if you have like compounding interest or something. So you might deal, if you want to look at that, that'd be great, but not too difficult. So we're going to talk about first the definition of an exponential function to the base of a. So here they define a to the x, okay, and that's going to be equal to ln e to the ln of a times x, e to the ln of a times x. Yeah, okay. So that's the definition of an exponential function to the base of a. So, I'm trying to think what the best. So they give an example where they tell me like a model. I don't like those problems necessarily. They are useful if you're actually going to be applying it to something. Do that one on your own after I talk about these more simple ones. So they also talk about a definition of a logarithmic function to the base of a. So a log base u by base a of x is equal to 1, so the 1 over ln of a by log of x, log x, times log x, okay? Basically they're just bringing everything into a form that is simpler, I guess. So you can bring anything in terms of another logarithm. So if you want log 10 of something, what you would do is you would have log 10. If I had log a of x, I would want log 10 of x over log 10 of a. That's the equivalent, okay? So I don't know if that makes sense, but basically if you want a logarithm with a base of anything, you have to, this is the equation to follow, where you take log 10 of what you're looking for divided by log 10 of a, and it's an equivalent representation. And that's really nice when you need to calculate something like that on a test, which you will maybe not have to do in college, but I had a couple times where I did. So I didn't necessarily know that going into that class, but I found out later, and it was nice to know. So this is the same thing here. We have a log n of x over a log n of a. So this is just the same thing, but with natural logarithm, where it's log base e. So that's kind of nice. So basically, the inverse of log a of x is a to the x. So that's it. It's no different than the others as far as definition is concerned. So let's solve for x in some of these equations. If we have 3 to the x is equal to 1 over 81, all we have to do is say log, let's take the log of both sides, log of 3 in this case, where 3 is equal to a. Log 3 of 3 to the x is equal to log 3 1 over 81. So here we have x is equal to log 3 1 over 81. And that's the way to solve it intuitively. Okay, we have 1 over 81. What is 3 3 to the power of x is equal to 1 over 81. Okay, that's obviously that's what this is, right? That's the way I think about it when I'm solving a logarithm. So what would 3 to the power of x be equal to? Well, so yeah, sorry. I know that's not like the most intuitive way to process it, but you could always bring it in another form if you wanted to. It's no easier. If you solve it, it's equal to -4. This is just bringing it in that form. Obviously, you can solve it both ways. But if you think about it as 3 to the what equals 1 over 81, well, that's equal to log 3, 1 over 81. Well, that's -4. Because 3 squared, 9, 3 cubed, 27, 3 to the 4th is 81. So 1 over 81 is -4. So, yeah, that's basic. Sorry if it wasn't like intuitive. They have another application where we do the opposite, but it's not really all that useful, I don't find. Let's do differentiation. It's really like pretty much the same thing as before. D by dx, they do some definitions here. Basically what I was doing earlier when I did these definitions, these are ways of solving them that involve normal bases. But you can solve for x not using this conversion to a natural logarithm. It's all about comfortability. I don't know if that makes it any easier, but whatever. Okay, yeah, let's do derivatives real quick. They talk about all these different kind of functions. I'm going to go through 2 and 4 because they're applicable. D by dx of a to the u is equal to log n of a times au du by dx. So that's that derivative, d by dx of log n, log a to the u is equal to 1 over ln a times u du by dx. So this is where it kind of gets a little weird because they keep normalizing by that log term. But I guess it's more simple than having all these different bases, which is possible. So you're kind of trying to normalize it all in terms of like one base, and they're choosing log it, like a natural logarithm, log base e. Sorry if I'm not like making sense. But these are the equations you need to know, and basically what I'm trying to tell you is that the logarithm is, the natural logarithm is log base e, and here they're just trying to normalize this. So if we wanted to evaluate it differently, we would look at exactly what we had done before with the just regular bases, and we're good. I hope that makes sense. So here, they evaluate these logarithms for differentiation, not too hard. So find the derivative let's do the first two of example 3, 2 to the x. What's the derivative here? D by dx. Now the derivative is log 2 to the x. Wow, that was hard, right? Not too bad. Okay, let's do 2 to the 3x, just to show you a simpler one, or like a little more complicated. We get log 2 to the 3x times 3, or we evaluate the u. That's not hard either. Hold on, did I do that wrong? No, that's good. If you want to, I mean, what they do is kind of dumb. They just bring 3 in front of log 2. So So what you could say is that we have a log and 2 to the third 2 to the 3x if you wanted to. I'm not saying you got to, but it's functionally equivalent, right? So that's easy enough. Okay, that's it for derivation, or differentiation rather, not derivation, differentiation. The last section will be a short one. I'm going to go over integration, and you'll be done with this unit. I'm going to plan for a test on Wednesday. Yeah, I'm going to plan for a test on Wednesday. I will have a study guide for you guys by hopefully Thursday. I think Thursday's fair. And we'll have a review Monday, Tuesday, or we'll have a review Tuesday. You'll have time to study on Monday, and we'll have that test by Wednesday. So sorry if it seems like this has gone like flying by, but I'm trying to catch up a little bit, and I feel like we fell a little bit behind. So let's tear through this section, and we'll have a nice test and get some more scores in the grade book. Okay. So that's it for this one.